Hello everyone, my name is Ijaz and I build projects in JavaScript environment, mostly with some AI, and share them here on YouTube. Today we'll be diving into the fascinating world of semantic search, and I'll showcase a project which combines the power of NextJS, openai and Pinecone. Pinecone is a vector database, we'll see what it is. I made a chat with PDF project earlier which also used the concept of semantic search. So I'll show you by example what exactly is semantic search, and then we'll go into the details. So on the right side, you can see on my screen, there is a list of ingredients that I have segregated into 5 categories. You can see we have category meat, which has a few ingredients. Similarly, vegetable, fruit, spices, and grains. Now these ingredients I have kept in the database, and I have just put it here for easy visualization. In reality or in actual applications will not do it. This I have kept it so that we see what is happening when we search, and the categories are not saved in the database. It's just over here that I have tried to segregate. Otherwise in the database we just have only the ingredients, that's it. And on the left side we have a search box where the user can enter any ingredient that the user can think of, and when the user will search that ingredient, we'll see that because we are using semantic search, so we will see that the results that come are very close. If the ingredient is present in the database, we'll get that ingredient along with other ingredients which are very close to what we were searching for. And if the ingredient is not present in the database, then again we'll get the results and it will be very close to what we were thinking of or what we were searching for. So we can think of like a grocery shopping application where the user comes, types in some ingredient, and the grocery shopping app returns the search. So let's say we wish to buy, the user is looking for tuna, and the user hits search. Now tuna, if we look under meat, so we do have tuna in here, so we should get tuna, and let's see what all do we get in return. Yeah, so over here you can see when we search for tuna, we got salmon and shrimp along with tuna, and we got pork and chicken. So the search understood that we are looking for a fish, and it returned other options, like we got salmon as well, then we got shrimp, and then we got pork and chicken. So it's a very good search, because like sometimes when we search in a grocery shopping, unless we search for something, so the shopping app gives us some suggestions, like search relevant to our results relevant to our search. Like they will pitch us to buy something else which is very much related to what we just searched for. So this is one such search, because we searched for tuna and we got salmon as well, so it's very nice. Now and the other thing is, when we search for tuna, it did not give us the results from anything from here. It gave us the results only from the meat category. So it's a good search. Let's try let's search for meat. Like I don't have meat as an ingredient over here, but yeah, I can see ground meat, but as such meat I don't have. Let's see what results do we get. When I search for meat, we got beef, pork, ground meat, bacon, and venison. Okay, so again it's a good search because the search understood that I was looking for meat. Like if we compare this with traditional search, so like which is a text-based search, so it's really tough to return results something like this. Semantic search, we can see that it understands what exactly we want. Now let's say that the user has come and the user wants to buy fruits, but user doesn't know which fruit to buy, or it's always like that. We just go and we just type fruits, and once we see some fruit, and then we say, okay, let's buy apples, let's buy grapes. So let's say the user comes and types in fruits and clicks search. Now you can see again we typed fruits and we got the correct results. If we go with the traditional search, it's I mean, normally how we have to implement is by tagging every item or every ingredient with a category and other keywords so that it can work. But over here, once I go through the code, I'll show that I have not done any tagging in here. One last search before we jump into the theory part. Let's say I want to buy orange, and I click on search. So over here you can see I got 4 results from fruits but 1 from spices. Now this could be what I think is that orange ginger juice is pretty common. So if you are looking for oranges, then maybe the ginger might be a good suggestion, because you might be looking also for, I'm not sure you will be, but yeah, a user might be looking for ginger as well to make orange ginger juice. So that could be the reason why. I'll show that we are using AI in here to create embeddings, and I'll show how exactly this search is being done. So I think you must have got an idea that semantic search is not a traditional text-based search. It's a search with a meaning. It's like asking a person, that person understands what we are asking for and suggests an alternative as well. Okay, so now we'll just go over the theory about semantic search and how I built this project, and then we'll go over the code in detail, and we'll see. So what is semantic search? Semantic search basically leverages natural language processing, NLP, and machine learning to understand the intent and context behind a search query. Whatever we query, whatever over here query means the ingredients that we were entering and hitting search. So that query is basically understood by the AI model, and then according to it we do some search and we get the results. It considers meanings, relationships, and concepts associated with the words we use. So it's not a text-based search, it's more into it. It's like how we think when we ask something from the shopkeeper, so the shopkeeper understands and returns if that item is found. Otherwise it gives us some alternatives that we can maybe consider if we think that suits our need. Now from here I'll show how we are actually implementing semantic search in our project. So first step is saving all the ingredients. Like when I was giving the demo, I showed that we have so many ingredients which are already in the database, but I was showing it on the UI just for easy visualization. So the thing is, we save all the ingredients in a vector database. Now vector database is different from traditional databases like SQL or NoSQL. The thing is, in these, I mean, it has this feature similar to insert, update, delete, normally insert, delete, query, and everything, but it saves. Normally we use vector database for saving the embeddings. Embeddings are a list. It's an array of numbers, mostly floating point numbers. So let's say that when we are saving the ingredients in the vector database, so how do we do it? So we have, like on your screen you can see we have n ingredients, 1 to n. So for each ingredient we generate an embedding. So let's say it has we have ground meat, so or we have goat, we have veal. So each ingredient will send that string to OpenAI's embedding model, and if you're not using OpenAI, you can use some other embedding models. So in this project we'll be using OpenAI embedding model. So this once we send a text to OpenAI text embedding model, it will return an embedding. Basically it will be, again, it's a list of floating point numbers which will have, it has the dimension of that embedding is 1536 dimensions, that's we say. So once we get that back, then we save it to the Pinecone database. Now what we do is we don't save all the embeddings one by one. We can do it, but we can also save like all the embeddings once we have, we can save it at once in the Pinecone database. Now over here you can see the structure of the data that we will save. We call it as vector. So it's a list. You can see it's a list, and each list, or it's an array, and it's an array of objects. Now each object has an ID. It can be any ID, like I just put it as ingredient, but it can be any ID. Then value, that values has to be embedding, which is returned from OpenAI. Then because vector database, if we query a vector database using an embedding and it returns an embedding, so embedding is actually of no use to us unless we know what this embedding is for what text. So that is why we can attach a metadata along with that object that we are saving, because so in the metadata we will save the text for which this embedding is. Let's say for the first object we have let's say we created an embedding for goat, so the values has the embedding for the text goat, and in metadata we will save text colon goat. We'll see how why it is needed. So again, we are saving all of this into Pinecone database and inserting and updating. It's like it's combined, we are saying is absurd. So we upsert, we call it as upsert into the Pinecone database. So once so this is like a pre-processing kind of thing. Before we can implement search, we have to pre-process all our ingredients, and we have to save all the embeddings in the Pinecone database or any other vector database you can, if you have, and it will go like this with embeddings. We'll save the text as metadata. Now comes the searching part. Now how to perform search. So this is the ingredient that the user has entered, and the user hits search. So what we do is, because our ingredients are saved in the Pinecone database as an embedding, so whatever user enters, it will be a text. So first we have to get an embedding of that ingredient, because Pinecone will not do text based search, it will do search with embeddings. So once we get the embedding from OpenAI, so it's like one API call we have to make, and we'll get the embedding in return. So once we get the embedding, next we will write a query to fetch all the embeddings, or not all, top 5, top 10, whatever. In the demo I showed over there, I was doing top 5 results. So the embedding will be a list of some numbers, list of floating point basically numbers. So once we query, what Pinecone database does is, it will, because every embedding is like a point in space. So when we query that embedding in the Pinecone database, what it does is it will look for all the it will look for all the embeddings which are close to it, and from there it will pick top 5, top 10 closest embeddings, and it will return. That's it. So over here it will return those embeddings along with the metadata, and then we will extract the metadata and will return to the user. Now the thing is, sometimes we can get results which are not relevant to our query. So let's say that we have a list of ingredients, but if I search for a mobile phone, or if I search for a table or a chair in this, I will still get some results from Pinecone, because it is doing a search. It is trying to find the embeddings which are closest to our query embedding. So it might get some embeddings which are far, but of course those are close, so it might return some results. So but that's not what we want to send to our user. So what we can do is we can refine it. So refining is where we will send the actual query and the results of Pinecone to OpenAI completion model. So let's say I searched for orange, and Pinecone gave me top 10 results from the database. Now I extracted the text out of those all 10 results. Now I send a query to OpenAI and I say, I am looking for oranges. Can you from the below results, can you give me top 5 relevant results. So now OpenAI completion model has the query as well as text list of ingredients, and now it will return us. We can ask it to return in the form of a JSON or a list or whatever. Now it will return back the result and we can send it to the user. So Pinecone will return the results, but if you want to refine it so that you don't get any incorrect results, so we can also use OpenAI's completion model to refine and make sure the results are perfect. So next we will jump into the code. I'll go through the code in detail and we'll see how I have implemented. And I have not implemented the refine part because yeah, I thought for semantic search, I think till the results returned from Pinecone were fine. But yeah, if you're looking for refining part as well, I did create a video on chat with PDF. Over there I have done the refine part. Maybe that can give you some help. Yeah, so now we'll jump into the code and we'll see how this project was implemented. So in order to start with this project, first we need an account in pinecone.io. So first we have to go to the pinecone.io and we have to sign in to create an account, and we get a free plan. And in the free plan, once you log in, you can go to API keys, and over here you can see the environment and value you will get. That we can copy and we can keep it. And the second thing is OpenAI, because we're using OpenAI models. So you can log into OpenAI and you can go to this personal over here and click on view API keys, and it will take you to this page. From here, if you don't have a key, you can create it by clicking on this page, on this button. Next, once we have the OpenAI and Pinecone DB keys ready, we can come to the project. Now this project is built in NextJS. I'm using Tailwind CSS for styling, and yeah, so I will be sharing the link for this repo. So what you can do is you can clone this project and you can put the keys, the OpenAI key, environment key, Pinecone environment, and key and environment. One more thing we need is Pinecone index. So what happens is Pinecone index is kind of a table in a SQL database. So it's a free plan, so I don't think it will allow me. Yeah, so it's a starter, so only one index is allowed. So what we have to do is we have to just give a name for index. So over here I have given the name as ingredients. The dimension has to be 1536. This should be the dimension, and the metric will be cosine. So it is something related to semantic search. With using cosine vector, we can it identifies the similarity between the embeddings. So once this is ready, so we have to put the environment, the key, and the index name in here. So once all the three is ready, you can like install the run npm install and npm run dev. Now I'll go over the code to explain. So now the packages that we need, I'll just close this one. The packages that we need. So we need two packages, two extra packages. One is, this is Pinecone node client. So this we can install, and the other one is OpenAI. But OpenAI it's not necessary, because if you're using APIs directly instead of a package, even that will work, not an issue. So next thing is we will now because we want to connect to the Pinecone database. So in order to connect, we should provide the environment and the key. So I have created one file, pinecone.js, inside the source the source directory, there is pinecone.js. So in here I am just configuring with initialize. What it will do is it will run init with the environment and API key. It will kind of connect with our vector database. So this is, I have kept it in a separate file so that we can reuse it wherever we want. And I'm exporting this Pinecone as this is a default export, and this will be whenever we want to initialize. This is a named export. Next is OpenAI services. So these are the configurations that I am going through first. One was the Pinecone, the other one is OpenAI services. So this is again one configuration file I have created for configuring OpenAI. So over here in the configuration, we just have to pass process.env.api key only if you're using npm package of OpenAI. And so we just have to pass OpenAI API configuration, and this object we can use. But because embeddings is kind of this creation of the embedding, we'll be using 2-3 places, I think. So I thought I'll put it in a function inside this file so that we can reuse it. So I created one function, get embeddings, and you can see it says openai.create embedding, and this request will go to the text embedding ADA 002 model, and we just have to send the text along with the model number, I mean the model name, and the data that it will return, or we can extract the embedding out of it. That's what the get embeddings function will do. I have created a get completion function as well, but we are not using it, but it will be here so that if you are interested in refining the results, so you can use this. So in this you can see we are using openai.create completion with DaVinci 003. We just have to send a prompt, and the tokens you can change, and the temperature it can be anywhere between 0 to 1. And once we call this, it will return us the actual text. So this is all from the OpenAI configuration. Yeah, next is the ingredients. I have around 100 ingredients split into 5 categories in the constant.js file that I have kept in the root of the project, that we will be using to update our database, and the same we will use to show it in the front end. So you can see it's nothing but an object with category and the list of ingredients under that category. Now the first step, like we saw in the slide, first is the pre-processing. Whenever we set up the project, before the user can come and search, we have to pre-process the data so that the user can do a proper search. So to pre-process, I have created an API under API process. Now it didn't have to be an API. It should actually be some kind of a script which the user does not have access to. Whoever deploys this code should have access to. But just for simplicity, I have put it as an API. So when you clone this project and you have set all the keys and everything in place, so first step is that from the browser or from the Postman or any, you just have to call this API first, localhost /API/process. So once we run this, it will take I think 5-10 seconds or a little more, and it will insert all these values in the Pinecone database. I'll show how it will work. So whenever the request comes, so this is our request handler. So as soon as the request comes, it will first get all the ingredients. So this is our ingredient function. So we have this all the ingredient array. It's an empty array. So it will get all the entries from the ingredients from the constants. I have imported this from the constants. So it will go over all the entries of ingredient, that is all the keys, and all the entries of the key value pair, so key value, and then we will concatenate all the values, that is for the meat, for the fruits, for the vegetables, for all the ingredients, because key is the category and value is the list of values. So we will just concatenate all the values, that is all the ingredients, and we'll return. Now once we have all the ingredients, we'll pass it to insert ingredients function. Insert ingredients I have written at the top. So this is where we are inserting in the Pinecone database. So over here you can see first we got the list of ingredients. Now first we are initializing Pinecone, and once we initialize, we will connect to that index. Now the index is ingredients, which we just created with the dimension 1536 in pinecone.io, and we'll have a vector array empty, because as we saw in the slide, we will insert all the vectors at once. We'll create an object and we'll put it in a list, and then we'll upsert all at once. Now we are iterating through each ingredient, and over here you can see I'm fetching the ingredient, and then I'm calling the get embedding function. It will be basically making an API call. That is why I have put await, because it's a promise, and it will then return an embedding. So once we get the embedding in this vector array, we are pushing this object. You can see it is the same object that we saw in the slide. We have ID as ingredient, we can put it anything, but the values has to be an embedding, and the metadata has to be some text. You can add more metadata, whatever you want could be relevant to your search. So once our embeddings are ready, once our vector has all the embeddings, we'll just go to index, not upsert index, we just connect it to our index, that's the index, and we will upsert all the vectors. You can see it has upsert request, and then inside that we have to insert all the vectors. So once it's pretty quick, once it is inserted, we'll just show that all the ingredients were added in our database. So this will pre-process our data, and it is done. Now the next part is query. So now the user, once this is done, the user can come and the search bar that we have, so over there on the search text box that we have, the user will come and enter some ingredient and hit search. So once the user hits search, we are making a post call to this API slash search, and the request will come here. If the request is not a post call, so we are just returning it. And then if it's a post call, we'll just see if we have a query. We should in fact do another check. If the query is empty, we should return an error. The next thing is we will initialize the Pinecone, and we'll connect to Pinecone index. You can see I did this before in the process API also. I have written this before generating the embeddings, because if there is some issue with the connection with the Pinecone, you will get the error before actually generating the embedding, because generation of the embedding will cost you money. So better do these things before when you know that Pinecone initialized, there's no issue, you have connected the index, no issues. Now you can connect, now you can get the embeddings, because once you get the embedding, it has already cost you, and then you face some issues with Pinecone connection, then that money is lost. So next thing is we are getting the embeddings, and then we make the query. I'm following the exact same step that we did in the search slide, because we were first getting the embeddings, then we were making a query. So this is an object, a query object that I'm creating, which I will pass in the Pinecone query function. So over here, query, we have to give a parameter as a vector, which will be our embedding. Then we will be asking for top 10, top 5, whatever it is. So we'll say top K5. Then include values and include metadata. We have to keep it true, because even without that, the query can return the results. So once we have the result, we will once we have the query request, we'll pass it to the index.query, and it will return the result. So from the result, it will actually be it's an object. From there we can get the property matches, which will return us an array. I mean, in the matches it has an array. So in the array, we will iterate through each item of this array and extract the metadata text. That's what we added in the process API. And once we have all the ingredients in the form of a list, we will return it back with what we queried and the response. And if there is an error, we will return an error. So over here you can see that this is how we are returning the list of results from the Pinecone database. Now I'll go back to the front-end code, which is in index.js. So in index.js, this is I'll just go through the API. Over here you can see I have an object for search box, and I have an object for list ingredients. So list ingredients is nothing but just simply listing of all the ingredients on the right side of the screen. Search box is our component that we'll go through, where we are making an API call for search. So once I come here, so you can see if I scroll down to the HTML, you can see we have a form, and this form has an input type text, which is asking for an ingredient. Then we have a submit button. Where is the type submit? Disable loading. Okay, so actually this has to be of type submit. Okay, and once we submit this form, whatever results we get, we are iterating, and we are displaying it here. And whatever we search for, we are displaying it here next to results. So we have two functions, handle change and handle submit. Handle change is because it's a controlled form, so we are capturing the input, whatever the user is typing. And in the handle submit, we are making an actual API call. So once we click on once we enter the submit button, so we are checking if the ingredient is empty and everything. And then we make an API call to a post call to API search, where we send the request with query and whatever ingredient that the user has typed. And once we get the result, we'll set the result in our use state. We have this results, and yeah, and this highlight ingredient is for highlighting the ingredients on the right side of the screen. So yeah, so this is how this whole project has been implemented. And yeah, for final, if I go for some spices, so you can see I got all the spices from the spices category. So I hope you liked it, and if you liked it, you may please click on like, and if you want to see more such videos, you can click on subscribe, and I will be sharing the GitHub repo in the description. And if you like the repo, you may start the repo as well. Thank you so much for watching. Bye bye.